In this video, we'll be talking about net force particle model worksheet 3, kinematics and Newton's second law. The problems on the worksheet require you to use kinematics formulas in addition to Newton's second law. Use the following steps in your solutions. Use force diagram analysis to find the net or unbalanced amount of force. List knowns and unknowns for force and motion variables. Force variables, acceleration, mass, net force. Motion variables, acceleration, initial velocity, final velocity, change in time, displacement. So this is the mathematical expression for the Newton's second law, and this is the mathematical model for kinematic equations. The variables that ties both lists of variables together is acceleration. Depending on the variables you know, you use either force or motion mathematical model for the solve acceleration, then use the acceleration value to solve the unknown quantity. Okay, right now we'll start solving the question. A race car has a mass of 710 kilograms. It starts from rest. Sometimes it is not given directly, but you see it starts from 0, right? So that means that initial velocity is 0. It starts from 0, travels 40 meters in 3 seconds. The car is uniformly accelerated during the entire time. How big is the net force acting on the car? Make a quantitative force diagram. Write a net force equation for the axis along which forces are not balanced. Okay, so if you think about a car, let's shrink to a dot. Okay, let's say that we are looking the car from behind. Okay, or let's say the car is going this way, and there is a force of gravity pulling it down, and there is a normal force X on the car, right? And then those forces are equals, and there is another force that make it move to forward. Let's say this way is forward. So this is the force diagram. Right now let's find them. Fg is m times g, right? So right now let's write this one down. So mass is 710 kilogram, and gravitational acceleration is 10 meter over second squared. Then from that, like 7,100 Newton is the downward force, and this one also should be seen because according to the Newton's third law, action-reaction pairs. Okay, now let's find this force. Okay, we're gonna find this force by applying some kinematic equations. Firstly, I would like to list the known. So here, you know that initial velocity is 0 because it starts from 0, and delta x is 40 meters. Delta t equals 3 seconds. What else we are given? Apparently, mass is 710 kilograms. Okay, so these are the equations. These are the known, and let's find the unknown. Okay, so eventually, let me write down here. Eventually, I have to apply this equation, right? Sum of all forces, or net force, equals mass times acceleration. Okay, So we are trying to find the net force, like what is the force acts on it so it moves, okay? We need to find that, right? In order to find this, we need to know these two. Mass, we already know that. Acceleration, we don't know. Okay, now let's solve for acceleration, okay? That is the part that we will find, and we're going to plug it here. Okay, now which equation we can use and find acceleration? Now at this time, I'm going to look at the equations right here, see which equation we can use, okay? So the method you can do that you can put the all equation in front of you just like this, and you can look at the known and you can figure out which one you can use, okay? I'm going to start from first one. Do you know V final? No. Do you know acceleration? No. I'm trying to find that. Delta T, yes. So you look at this, guys. There are two unknown here, so I cannot use that. I'm going to try to find the one that has a one unknown, so I can solve it for acceleration. Delta X, do you know? Yes. Acceleration, you know? No. That's I am trying to find. Delta T, yes, I know. Initial velocity, yes, I know. Okay. So I know delta T, but this part will be 0, okay? So we decide that we need to use the second equation, okay? So I'm going to write it down. In order to show my work, I'm going to write it down. So let's write down delta X equals 1/2 acceleration times delta T squared plus V initial times delta T, okay? This part will be 0 because initial velocity is 0, right? So let's plug everything we know. Delta X is 40 equals 1/2. Acceleration is the question mark I am trying to find. Delta T is 3 seconds squared. Then plus this part will be 0 because initial velocity times time is going to be 0. So right now, let's solve it for A. Okay? Let's solve it for A. So let's multiply both sides with 2. Let's multiply both sides with 2. Then it's going to be 80 meters equals 8 times 9 seconds squared. Let's divide both sides with 9 seconds squared. So then acceleration will be 80 meter over 9 seconds squared. From that, so let's put in the calculator 80 divided by 9, that equals 8.8, so we can say that just 8.9 meters over second squared. That's it. So we found the acceleration. What we need to do is just put this acceleration in this equation. So I think I am out of this space. I'm going to just use this space, okay? So let me rewrite the equation. That is the equation, remember I am using, okay? So mass times acceleration, net force is, mass is 710 kilogram times acceleration is 8.9 meter over second squared. From that, again, let's put in the calculators. 8.9 times 710, that will give you net force is 6319 Newton. Okay, 6319 Newton. So with this, we are done with the question.